Hi, this video is about conservation of momentum, mostly because it was requested by some people that I start making videos of the math. Quick review of what conservation of momentum is. We talked about this in class. First, there's a joke here. If you remember last week, momentum is mass times velocity. So anything that is moving and has mass has momentum. The more mass it has, the more momentum. The more speed it has, the more momentum. When we talk about conservation of momentum, if you remember back to the Bill Nye, he talks about how momentum can be transferred. This little joke here, you've probably seen a Newton's cradle before. These would be replaced with steel balls, and they click back and forth. And so a little joke, why science teachers should not be given playground duty. Ha ha. Quick reminder of what the law of conservation momentum says is it says there's fancy words that were in the reading. Otherwise, it's literally a group of objects that are interacting. The total momentum of those objects always remain the same, no matter what happens, as long as there's not another object or another force that is added. So if they just sit there and they don't collide, then the momentum is the same. But if they do collide in some way, there is no momentum lost. There is no momentum gained. It is simply just transferred between the objects. And I talked about these examples in class, the Newton's cradle. These video links are in the notes. If you want to watch them, you can go ahead and do that. Another simple one, when you jump into a pool or even to a puddle, your motion, your momentum is transferred to the water, which is why the water moves and splashes. But if we are going to look at the math examples, and I'm going to move I'm actually going to take my face out of here, guys. Sorry. I'm going to try to get my face out of here. Never mind. I'll just move it up. So we have this example of a red car and a blue car that are going to collide with each other. You have a red car that has a mass of 1,000 kilograms and is moving at 6 meters per second right. It collides with a 500 kilogram blue car initially at rest. They stick together and move right at a velocity of 4 meters per second. Complete the table to show that momentum was conserved. So what we're going to be looking for to show that momentum was conserved is over here in this corner. We should get the answer 0 because before the collision, after the collision, they should be the same number. So there should be no change in momentum. I'll get rid of that. And so let's do the math. So if I talk about the red car, here's 1,000 kilograms, 6 meters per second right. On these problems, you're going to need to convert the rights and the lefts to positive and negatives. So if I'm doing the momentum, and we'll just put a little note up here that momentum is mass times velocity. So of the red car, I have 1,000 kilograms, and it is moving at 6 meters per second right. Right is a positive number, so it's positive 6 meters per second. So when I get those, I'm going to get a positive 6,000. And remember, the units are just kilograms times meters per second. I then have a blue car. I don't think the blue is going to show up. I'll use that as green. 500 kilogram blue car that is at rest. Well, 500 kilograms times rest is 0. Gives me an initial of, that's a silly mistake, 0. When I add these numbers up, so system before is just add red plus blue. So I have positive 6,000 plus 0, which gives me positive 6,000 kilograms times meters per second. Then we have a statement about after the collision. After the collision, they stick and move together at a velocity of 4 meters per second. So both of them are going to be moving at 4 meters per second right. The mass doesn't change, so I still have 1,000 kilograms for the red car. But now it's moving at 4 meters per second, right? So times 4 meters per second gives me a positive 4,000 kilograms times meters per second. The blue car is still 500 kilograms. and it is moving again at a positive 4 meters per second. So I'm going to get a positive 2,000 kilograms times meters per second. Adding those numbers up, I have positive, I'm going to go, trying to keep my color scheme going here, guys. I have positive 4,000 plus a positive 2,000, positive 6,000 kilograms times meters per second. Last column, the change momentum, and you need to do them in the order of after the momentum after minus the momentum before. So I will have a positive 4,000 minus positive 6,000. So I'll have a negative 2,000 kilograms meters per second. For the blue car, positive 2,000 minus 0 gives you positive 2,000 kilogram meters per second. If you look at the system together, I have positive 6,000 minus positive 6,000, which is going to give me 0. So what you can see from this, 0 change. And the reason it's 0 change, if you look at the red car, negative actually lost momentum, negative 2,000, but the blue car gained 2,000 in momentum. And so the amount of momentum lost by one is the exact same amount that is gained by the other to have an overall change of 0. I'm going to do one more example, because this time both cars are moving at the beginning. In the first example, only one car was moving. Start with the red car. Again, you have a red car at 500 kilograms moving at 10 meters per second right. So I'm going to start that one right away. 500 kilograms times, again, right is positive 10 meters per second. This will give you a positive 5,000. You have a 500 kilogram blue car, and it is moving left at 8 meters per second. Left is negative. Negative 8 meters per second. This will give you negative 4,000. Your overall, again, I'm just going to add them up. Positive 5,000 plus negative 4,000. It's going to give you positive 1,000 kilogram meters per second. After the collision, they stick together and move right at a velocity of 1. So both of them are moving right at a velocity of 1. So 500 kilograms times positive 1. It's going to be positive 500. The blue car is the same size and the same velocity. So you will get the exact same answer. And when I add them up, positive 500 plus positive 500, it's going to give me positive 1,000 kilogram meters per second. Now you can already see that 1,000 before, okay, I have 1,000 before, I have 1,000 after, so that's a good sign. You have after minus before, so positive 500 minus positive 5,000 equals negative 4,500 kilogram meters per second. Again, after minus before. Change colors. Positive 500 minus negative 4,000 is going to equal positive 4,500. Sorry, it's a terrible 5. And when I look at the system together, I have positive 1,000 minus positive 1,000, which is going to equal 0. So you can see again that momentum is conserved. Hopefully this video will assist you when you are doing the conservation momentum problems.